Hi, everyone, and welcome to Spotlight with Scientists in School. I am so glad you're joining me today because I have a special guest. With me is Laurie Russo-Neptun, and she is a resident astronomer with the Canada-France-Hawaii Telescope, which is actually in Hawaii. So you are joining us all the way from the Big Island. And I'd also like to say that Laurie is got her PhD actually in Quebec, right? Would I assume it's Laval?
Yeah.
Right?
Yeah, exactly.
Exactly. And Laurie is also the first Indigenous woman to get a PhD in astrophysics in Canada. So, wow, that's exciting to have you on the show. Thanks so much for doing this.
My pleasure. Yeah, it's nice to talk to you.
That's great. So let's start at the beginning. I want to know about your journey. How is it that you came to love stars and then study astronomy?
Yeah, that's a good question. Where did it start? I can only remember when I was young, I always loved looking at the stars, and with my family, we did spend a lot of times, after those long summer night by the fire outside, we would just lay down by the lake on the deck and we would look at the stars. And if there was any, shooting stars or things like that, we were kind of like competing to catch us like as much as we can and things like that. And so for me, it was part of my youth and also part of, when you're young, you're curious. So I was always asking questions, and understanding the stars, understanding the sky was something very important to me. I was asking a lot of questions about it. So I think it started very early on.
Very early. Curiosity, that's the thing, right? Asking lots of questions. Now, what you're doing right now is you're observing, I think it's called Signals, right? A program called Signals, yes. And you're observing a lot of the night sky. Before we get into that, how about if you just let people who are watching know what makes a star a star? You talk about nebula, yep. Galaxies. Yep. What are those things?
Yeah, there's a lot of mysterious things in the universe. So when we look at the sky, we see a lot of stars. Those stars are our neighbors. They are like the sun. Some are small, some are big. They can have slightly different colors, but what ultimately makes a star is that it produces light. There's a magnificent, like a magical reaction happening in the heart of the stars. We call it nuclear fusion, and it produces a lot of light. So they shine, and they can shine for very long, some shorter, some longer. And nebulae is something different. It's bigger than a star. It is clouds of dust and gas in galaxies. So stars and nebulae are inside galaxies. But this gas is very important. It's actually part of what I study. I'm going to talk a little bit more about that, but gas is important in galaxies because it can form stars. And so with time and the force of gravity, it can collapse and fabricate new objects. And then galaxies are much bigger. So galaxies are a huge object that contains billions, hundreds of billions of stars sometimes, and even more sometimes, and lots of gas and lots of nebulae. And everything is kind of bound together by gravity. Most galaxies also have a rotation motion. They rotate, but it takes forever to rotate. For a galaxy, it's like 250 million years for one turn. Yes, they're big objects.
So can you describe what you do in a typical day? Like, what is your job as a resident astronomer in Hawaii right now?
Yeah, I would separate it in like 3 parts. The first part is I help people. So I am an expert in doing observations. So I know very well the cameras and the instruments we use on the telescope to gather data. So I help anybody on the planet, astronomers or students, to observe with our telescope with the different instruments we have. And then I conduct those observations for them and I send them data. And the second part would be my own science. So I, just like them, like to study specific things and gather data for my own project and study it. So it also involves students and collaborators and a lot of interactions with people a little bit everywhere. And finally, improving those instruments, improving those cameras that we use to look at the sky. So it's a little bit more hands-on, a little bit more engineering in a sense, even though I'm not an engineer. So I work with engineers on that. And we try to make them better, and so that they can look at the sky and the universe and tell us more about it.
So you kind of are touching upon my next question. Why should we look at the stars in the sky? What do you want to know, or what is all this information telling you?
Yeah, it is a good question. When you start studying astronomy, you don't know necessarily what is so important, but you get to it very quickly. Stars are what I would say, what drives the evolution of the universe. So our universe, we've learned a lot about it in the last 100 years. We know that billions of years ago, it was very different from now. It actually transformed itself. Since the very beginning, when we call the Big Bang, which is not necessarily a beginning, but like a moment when the universe was super dense and there was no galaxy, no stars, just like particles and light. And it started expanding. And eventually, with this expansion going, it cooled down and formed the first stars and the first galaxies. And all of these objects interacted by gravity, and galaxies, with time, they tend to merge with each other to form larger galaxies. And within those galaxies, stars are active. They keep shining, and they keep doing that magical reaction that I was talking about, that nuclear fusion. And that's the key of the chemical evolution of our universe, because nuclear fusion fabricates new elements, new atoms. It fuses small atoms into larger ones and create atoms like carbon, oxygen, things that you might be a little bit more familiar with that we have in our environment on Earth. And
Right.
so the universe at the beginning would probably not have been able to form a system like the solar system and Earth. But with time, it got a lot of material to do that because of the stars. So they are at the heart of all this, and they keep going. So we'll see in the future what's going to happen to the universe because of that constant fabrications of new elements by the stars.
And you're getting all this data from the telescope that's in Hawaii. Now, I said it's called the Canada-France-Hawaii telescope. So obviously there must be some collaboration between those countries. But why did you put it in Hawaii? Why is it on the Big Island? Why choose that spot?
Yes, so Hawaii is such a special place. We are in the middle of the Pacific Ocean on this island. The Big Island of Hawaii is the largest island. It's also a volcanic, actively volcanic island, so there's volcanoes. And it has very tall mountains that are sleeping volcanoes, sometimes active volcanoes.
Yeah, I hope they're dormant. I hope they're dormant where you're working.
Yeah. One of them is the Mauna Kea. So the Mauna Kea is it's a Hawaiian word. People thought it meant the white mountain. Mauna, mountain, Kea could mean white, but actually, if you ask an historian in Hawaii, they would tell you that it's the Mauna Awakea, which is the god of the sky for the Hawaiians.
Oh.
And for them, it was a connection to the sky, which I think is beautiful, because we're observing the sky using using this wonderful mountain, which is 4 kilometers high, more than 4 kilometers high. And
wow.
So that's one important part. Being up there, you're often above the clouds. So you have to, most of the time, go and cross this layer of clouds while driving up, and you get to the top so you can observe the sky very nicely. Then there's another thing that is a little bit less trivial. So we have those trade winds on the island that goes from east to west. And they are not perturbated by any other structure because we're surrounded by the ocean. So you have this flow of air coming east to west, slowly gliding above the summit. And this enables the stars to be very, very pointy and very small on the images. So there's no twinkling, if you like. Anywhere else on the planet, if you have mountains, buildings, things like that, the wind starts to make those kind of swirling motion. It makes stars twinkle. And we don't want that to be observing the sky. On top of that, we don't have big towns around. We do have Kona and Hilo, which would produce a little bit of light pollution. But because of the whole setup, most of the time, clouds are covering those towns and block the light from the summit. And so we have beautiful dark sky at really high altitude with no twinkling. All the elements are there.
It seems like the perfect condition then to be studying the stars on top of this.
Oh yeah, definitely. Yeah, and it's very, very rare on the planet.
And do you get altitude sickness at all going up at that height, or how do you combat
Yes,
that?
yes, you can. Yes, we have some safety training to do before going up there to know how to handle it, how
Okay.
to prevent it, and how to recognize symptoms if they show up. I'm lucky. So far, when I go up there, I don't have too many symptoms, but it can vary from one person to another, and there's no way to predict if you're going to be good or bad up there.
Ah, yes.
Yeah, even if you're in good health, good shape, you might be the person suffering the most of the high altitude sickness. And if you have some people that do not train and go up there and have absolutely no problem. So, so we have to be ready for that.
Yes, and I know from personal experience because I'm one of those people. I climb Mount Kilimanjaro, and unfortunately, I was the one person in the group that I thought I was going to die. It was the altitude sickness, like you said. You don't know who it's going to affect, and you don't know how you're going to react. And so that's why I was wondering with that height if you had those experiences. Interesting.
Yeah, we do. Yeah, we have to be ready for that.
Yeah, you have to be ready for it. Now, the other thing I'm wondering, if it's such a perfect spot for a telescope, are there other telescopes? Are there other countries that have drop telescopes there too to observe?
Yes. Currently, we have 13 telescopes, which some of them might include more than one unit. So some people might look at pictures of the summit and see more than 13 telescopes, but there's actually 13 facilities on the summit, one of which is in decommission, so they are deconstructing it, but the other 12 are still active.
And are they all collecting the same type of information, or are some telescopes looking at different things?
Completely, yeah, they are most of the time completely different. So we have telescope from the radio wave, so light, that's what we study in astronomy, that's what the telescope are gathering, and it comes in different energy, and depending on the energy of the light, it has a different name. So we call it we can call it like radio waves, infrared, submillimetric waves, visible, that's the most common one, and infrared. So those different band of energy are targeted by different telescopes.
Now, I read that these telescopes have to stay really cold. Why is that? And is that true? Did I read correctly?
It is true, yeah. So especially the cameras and the instruments. So there's one very good reason for that is that if an instrument, a camera is not cooled down, it will start to emit its own light. And just like our body, the human body is also emitting light. We just don't see it. It's in the infrared. But if you have very special pair of goggles like the one they have for like night vision, well, then you can see the light emitted by the human body. It's the same for those cameras for any object. So by cooling them down, we kind of reduce the amount of light that they produce. And when we take an image of a galaxy or a star, the light that we detect is really the light coming from space and not from the surrounding environment. So that's the main reason for that.
That's fascinating. All of it is so fascinating. I can listen to you forever talking about the stars in the sky. I'm going to switch gears just a little bit and talk about your degree when you went to Laval to get your PhD. You're not the first female in STEM that I've interviewed that has a similar story, that in your cohort, I think it said there were only 3 other women. Right? And there were 33 males.
Yeah, when you register to a program like physics, you kind of expected it. I remember when I was young, I was expecting it. I knew it was going to be like that. I didn't know necessarily how well I would do. I had a very positive experience with the other students by, feeling integrated in the group. And I think that I was lucky in a sense. It's one of those other challenges that women have to face is to feel like they are going to be accepted by the group, to feel like they belong. And if you have only a few women in the group, it's much more likely for you to have a hard time. So I feel really lucky to have ended up in a very nice group of people that welcomed me. But still, there's always something that comes with it, and I think I would describe it as like a personal pressure or stress that you impose to yourself to perform. It comes just naturally in a sense. It's really not a good thing, but since you're representing a smaller group, you want to make sure that you're going to shine, you're going to be good. And people are not going to say, oh, she doesn't belong here, or she's not good enough because she's a woman.
Right.
And that always followed me, just to make sure I was keeping up and representing the women in my group.
I was going to say, did you feel that same pressure being an Indigenous woman in STEM? And you are the first woman to get a PhD in astrophysics. What did that mean to you personally? And did you feel that pressure?
It came as a shock to me. So I remember it's a journalist that called me and asked me the question. And astronomy is a very small field in Canada, so I knew that I was the first one, but I had never realized it. And when I fully realized it, I had really mixed feelings. It was a shock. I was kind of, I couldn't understand how did that happen. How did me, I ended up with my PhD in 2017. How could I be the first one in 2017? That doesn't make any sense.
Right.
It could have been planned before me. It did came with some responsibility that I'm fully happy to fulfill. I think that more people should jump into that field. It's a wonderful, astronomy is a wonderful field. It's good jobs. It's actually fun. If you're curious and you love astronomy, you should feel like you can do it and you belong there, no matter where you're from and what is your background. So I'm happy to fulfill that, but it does come with some responsibility. I think so.
Have you heard, I'm sure you've heard lately the terms indigenizing STEM in schools. What are your thoughts on that? And what do you think that really means?
Yeah, it's very important to me. So I was in part of a group that wrote a letter for the Canadian Astronomical Society for what we call the decadal survey. So for the next 10 years of astronomy in Canada, what are we going to do? And we talked about indigenizing astronomy. And so what does it mean is basically being more open-minded. Astronomy can be, very academic in a sense, the way it is presented, the way it is taught in schools. It was done in a way, in a framework that has never changed for decades, and that has never fully included the contribution of everybody. And it is important to include that so that people can see how their own community actually participated in these challenges, like in answering those questions that everybody is asking about space, about the universe, about our origin, things like that. So that's one thing. And so including the knowledge coming from everybody, and including the way this knowledge is also shared. And I think that's a good start so that people feel a little bit more welcome in the field, and to create an environment where you're not the only one. Like we were talking about the fact that I was 1 out of 3 women. For me, I was lucky, it worked out, but it could be also a challenge for some people. And if you start a program and you don't feel like you belong, you're just gonna give up, and it's not going to be your fault. It's not because you don't belong. It's not because you're not good enough. It's just because the surrounding environment is not suited for you. So we want to avoid that. So there's a lot of different steps that we need to go through to indigenize astronomy so that everybody feels welcome. And I think indigenizing astronomy is probably very specific to the situation of Canada, but it could also mean just including more people, more way of thinking, and it is going to be good for science. We need those different minds, those different ways to tackle problems. And I think that my own background, my own education, who I am, helps what I do in my research nowadays. So it is really important.
Oh, absolutely. See, when I went through school, astronomy was very Eurocentric. All the stories that we learned about the stars, it's a lot of Greek words, Greek mythology. I'm wondering if you have a story of stars in the sky that you could share from an Indigenous view for us.
One thing that I'd like people to probably keep in mind is that through time, people thoughts about the universe changed a lot. And if you look back hundreds of years ago around Canada, it was very common for a lot of the nations, the different nations, which there's a huge diversity of different ways of seeing the universe, depending on where you are in Canada, but I don't want to generalize, but a lot of the communities had this belief that we came from the stars, and that when we die, we return to the stars. And it wasn't necessarily something that was shared by the rest of the world. And if you look at modern science nowadays, it is much closer to reality, because we do come from the stars, and those stars that produce those elements I was talking about. I think it's beautiful to think about that.
I do
that
too.
in some way, yeah, those thoughts, those hypotheses were more accurate.
Yeah.
And so that's one thing. There are also other stories, and one of the aspects of the Indigenous stories that I probably would like to highlight is the fact that they are always presented in a context. When we study in school and academia, you learn about some very specific topics like gravity, and then you learn about gravity and how it influences celestial body motion and formations of stars. It's like in one little block.
Right.
A story would have not one element, but many elements that are interconnected with so many other fields, and they cannot be dissociated, because everything is connected. So that's one of the aspects that I also really like, and I think we should incorporate in our way of teachings in school. You cannot always separate topics like that. Right. They have to be embedded in a context. And so there's a story that I really like that is part Innu, but part other communities. So I'm Innu, but so of course I'm proud of that one, but I know that other communities share that. Yeah. And it's a story about a celestial canoe in the sky, which contain many spirits that paddles in this canoe, and two are very important: the wolverine Quiquachu and the fisher cat Uchek, and they also corresponds to stars in the sky. And this canoe is traveling from north to south every year, rotating around the North Star. And in the story, the animals are going to deliver, or to help the summer birds to be released. They are trapped, and they bring back the summer to the north. And I'm trying to give you a very short version, because that story could be very long. But while they do that, and the birds are associated with the Milky Way, and the Milky Way is included, it's beautiful. And so the birds come back to the north and bring back the warmth with them. And it is believed that this story is thousands of years old and is associated with the melting of the glacier after the interglacial age. After the glacial era, that was basically very predominant in Canada about 15,000 years ago. So that's one example of a good Indigenous story that is informing us about what happened in the past and how it was kind of interconnected with celestial motions and things like that.
I love storytelling. I love learning about our place in this planet through these types of stories. And like you said, it's not just Indigenous, you find them in so many different cultures.
Presenting different ways of seeing the sky, different theories, different stories is important, because we just don't know which one's going to be the most accurate one. Right. And that's why I kind of like the we come from the stars example, because it took how many years before we got back to it. And so I think that it is still relevant, because when you are building your own kind of scientific brain, you want to keep all the doors open. If you are open-minded, you're going to be a better scientist, because you're going to look in all of the corners, And so as a teacher, if you are incorporating those different ways of seeing, those different ways of teaching, of learning, you're going to enable your students to do great things. And you shouldn't present a model or a theory as the wrong one versus the good one. You
Right.
can always say these are different ideas, and
Right.
this is the most accepted ideas nowadays, but you just have to be more sensitive about how
Right.
you present it.
Um, Before I let you go, I do want to know that if you had to live somewhere other than Earth, because you've been looking at all these galaxies, where in the universe would you want to live?
That's a good question. You know, I think that a lot of people in science fiction would pick a planet, would pick a moon,
Yes.
but at the end of the day, I think I'm good with our own planet, the Earth. If I had to pick, I would stay here.
You'd still
Yeah.
stay on planet Earth.
Oh, yes. It is so beautiful.
Yeah.
I am like I was saying, I'm always curious about like everything that I see in the nature, and I'm always surprised and amazed by it. And now I'm in Hawaii. I have a different environment to explore, and when I come back home, when I go to my home territory, I'm familiar with the things that I see. But even though every day I discover things,
Yeah.
and I think we are lucky to have this diversity, and we need to preserve it. I don't think it's going to be that easy to find something as special in the universe.
Well,
Yeah.
this has been so inspirational. Truly, you remind us all that you really can look at the sky and reach for the stars. Thank you so much. Take care. Bye.
Mahalo. Bye.